This is Unit 5 Nomenclature, Lesson 6, Video number 1. So in this one, we are going to be looking at how to write chemical formulas. So we're given the name, and now we have to reverse what we've been talking about with nomenclature and write down its formula. This is probably going to be the more useful of the tools that we have. And this is going to be for ionic compounds. We already looked at how to do this for covalent. So the instructions are over here. We're first going to write down the symbols for the elements or polyatomic ions, whichever one is given. We just have to be able to recognize polyatomic ions. Usually a lot of them end with ate or ite. Determine the charges of the cations and anions using a periodic table. So we have the charges, we have our charge card, and we have stock and traditional terminology. So if you're given a Roman numeral or an ich or an us, we should be able to reverse and figure out what charge it is. Write the charges above each ion, and then we're going to cross the charges. The charge becomes a subscript. We're going to put parentheses around anything that's polyatomic because we know that parentheses group that. We're going to reduce the subscripts to lowest terms if needed. And if we have a subscript of 1, we know that those are never ever written. And if we have parentheses around something with no subscript on the outside, we can remove the parentheses. So what we're going to do is follow this as we look through several examples. So we'll start rather easy. Here's our first example, sodium sulfide. So we know sodium has a symbol Na. Sulfide refers to our element sulfur. So we write an S. Now we have to determine the charges. So if I go to the periodic table, sodium can only be +1 and sulfur is -2. Remember that they're always written, the positive one and then the negative one. Now we're going to cross the charges. So the 2 up here becomes a subscript down here on sodium, and the 1 on the sodium becomes a subscript down here with the sulfur. So we end up with Na2S1. Reduce the subscripts to lowest terms. 2 and 1 cannot be divided by a whole number to give us a whole number, so we're in lowest terms. And then this is not needed. So our final answer is Na2S. Here's our second example. That's a scribble right there. Nickel, Roman numeral 3, oxide. So with this one, nickel is Ni. This right here is a clue. This tells us the charge of Ni, not its subscript. Its charge is +3, so I'm going to write that above there. Oxide is oxygen. It has a -2 charge. So when we cross the charges, we get Ni2O3. It's in lowest terms, and we don't have to reduce anything. We don't have to cross out or remove any unneeded things. So Ni2O3 is its proper formula. Our third example, aluminum phosphate. So aluminum is Al, phosphate is a polyatomic, so we have to look that one up, PO4. Now we have to worry about their charges. So aluminum on the periodic table only has one possibility, +3. Phosphate, if we look it up on the charge card, is -3. So when we cross the charges, we get Al3 PO4, 3. We have to put parentheses around that because we need 3 of this group. This is not in lowest terms. 3 and 3 can both be divided by 3. So we get Al1, PO4, 1. The 1s are not needed. So we get AlPO4. And parentheses are not needed because now we only have one PO4. So AlPO4 is our final answer. You don't have to write out each one of these. If you see that something is positive 3, negative 3, they're the same number, opposite charges, that means it's always going to reduce down to 1. So you could go directly from here down to here, knowing that when you cross the charges, they cancel each other out. Auric hydroxide. So, auric refers to gold, whose symbol is AU. But this one has an ick on the end. That tells us it is the higher of the two possible charges on gold, so that means that it is +3. Hydroxide is a polyatomic. It's OH and a -1 charge. So when we cross the charges, AU has a 1. We have to put parentheses around the OH and put a 3 there. But we know that that 1 is not written, so we end up with AUOH parentheses 3 as our final answer. Let's look at one more example. Tungsten carbonate. We don't really talk about tungsten that much, but its symbol is W. Carbonate is a polyatomic, CO3. The charges, tungsten only has one possibility, +6. Carbonate, when we look it up, is -2. So we cross the charges, W2, parentheses, CO3, 6. 2 and 6, not lowest terms. We can divide both of them by 2. So we get W1, parentheses, CO3, 3. Well, that doesn't look quite right because we don't need the 1. So we get W, parentheses, CO3, 3 as our final answer. So you should be good to work on the worksheets. I have separated the first 2 worksheets in this lesson into monatomic and then one with polyatomics to make it a little bit more easy.